Hello, my name is Jim Morhard, and I'm the Deputy Administrator at NASA. On November 2nd of 2000, the Expedition 1 crew of Commander William Shepard, Sergei Krikalev, and Yuri Gudzinko arrived at the International Space Station. Since that day, we've had a continuous human presence of astronauts living and working aboard the world's only orbiting laboratory. The International Space Station is one of the most ambitious international collaborations ever attempted, and is a convergence of science, technology, and human innovation that provides humanity a one-of-a-kind proving ground for Artemis as we go forward to the moon and then on to Mars. It's a demonstration platform for new technologies and a research laboratory for breakthroughs not possible on Earth. It represents the most complex space exploration program ever undertaken. And in the 2 decades that humans have inhabited the space station, we've used the unique orbiting laboratory to build our understanding of how humans can safely live in microgravity. We've made groundbreaking advancements in medicine, and we've tested technologies that will help us travel farther into space. At the same time, we've gained new insights into our home planet on Earth, and we've stimulated an emerging low Earth orbit economy. On behalf of NASA, congratulations to the International Space Station program and all of our international partners on this historic milestone. We look forward to what the next 20 years has in store.
Hi, I'm Jean Meserve, and it's my pleasure to host a conversation that really is life and world changing. Today, I am joined on the program by the 5 primary partners of the International Space Station. Let me introduce them now. Joel Montalbano of NASA, Frank de Winne of the European Space Agency, Luc Dubé of the Canadian Space Agency, Junichi Sakai of the Japan Aerospace Exploration Agency, and Sergei Krikalev of Roscosmos with the Russian Federation. Welcome to all of you. Great to have you with us. And a special thank you to NASA for their assistance in assembling these leaders, and to the Space Foundation Space Symposium 365 platform. And now, let's go. Joel Montalbano, let me start with you. A lot of relationships don't work for 20 years, but this one has. Can you explain why this relationship is still going on and successfully?
Well, excellent question, and hello to everyone, and thank you for getting together today. You know, to me, it works because we help each other, we learn from each other, and we cooperate from each other. You know, throughout the 20 plus years of the International Space Station, whenever we've had a challenge, there's another partner that's always ready to step up and help wherever they can. Across the 20 plus years that we've seen operations of the International Space Station, you know, we've had those opportunities, and every single time a partner has reached out to another partner when they were in need. And to me, that has been the biggest success of the International Space Station.
Sergei Krikalev, do you want to weigh in on why this has been successful?
Joel already mentioned it, that this probably was successful for the last 20 years because it's really started earlier than 20 years ago. We started our first joint mission in 1975, Apollo-Soyuz mission. We started our joint flights on shuttle and on Mir station in beginning of 90s. So in middle of 90s. So I think the main reason why it works after that was because we have a really strong desire to do this. And this was first part. And second part is that we have very good professionals who was doing this. Because good professionals have really big desire to be successful. We were successful for these 20 years.
There are, as you all know, skeptics on Earth who are asking, why are we spending this much money on space exploration? Mr. de Winne, can you tell us what value the space station has brought to people on Earth?
Well, one of the biggest values, of course, is the cooperation itself. And we see around the world, it's not always so easy for big nations to work together And this partnership has shown that if you have a common goal, if you want to work together, that you can achieve great things. And I think the example that it sets in that area is tremendous. But it has also brought very specific results. For example, ESA has done the experiment airway monitoring, where we studied the lung functions of astronauts on board of the space station. Well, the results of that research have led to new technologies, new tests that can be used on asthma patients. And as a result of that, 300,000 patients have been tested. 36 million tests have been performed, and those patients have received specific medication for their disease. So it had a direct impact on their quality of life. Another example is, for example, the Melfi freezer that we have on board of the International Space Station. It freezes our samples up to -80 degrees. Well, the technology that is used to maintain those kind of temperatures on board of the International Space Stations is now used on big ships that transport gas. And this gas that normally boils off can be recycled. And due to that, we are recycling per year 100,000 tons of CO2 carbon emissions, meaning that it has a direct impact on fighting climate change. These are only two examples, but I know that our partners across the board have many more, have thousands of examples, how research, innovation on the International Space Station has directly impacted the life of the citizens around the planet.
I'll say a couple things. On the, Frank mentioned the freezers we have on board and the -80 degree freezers. Because of the assets we have on the International Space Station and the need for us to transport across the globe, we have reached out to help these drug companies that are about to start distributing the COVID-19 vaccine, and using our experience and offering up this experience that we have globally to help this global pandemic. So to me, it's just one of the many examples where we can capitalize on the International Space Station and what we've learned over these 20 plus years to help others and to benefit humans on Earth.
Political winds blow, leadership changes. Joel Montalbano, let me start with you on how you think these sorts of changes impact the International Space Station.
Over the 20 plus years, we've had leadership changes in all our agencies and the governments associated with them. And, throughout that, the standard that's been cooperation. And we've been able to cooperate while meeting the different national priorities of the different agencies. And to me, the benefit of the International Space Station is we work on a physics-based, and physics is the same across the globe. So regardless of any political change and leadership change, we're able to manage and operate the International Space Station. We're able to communicate because we're communicating in a physics type method. We're able to operate and stay below any political type challenges, but we still are able to meet each agency's national goals. And so to me, that's, again, another benefit of the International Space Station. And I'll open it up to any of my other colleagues if they want to add to that.
Does anybody weigh in on that, on the changes in political leadership? Okay. Well, your agencies have worked together for 2 decades now, amazingly. What are some of the things that you are able to do now that you could not do 20 years ago, 15 years ago, 10 years ago? Mr. Dubé, why don't you go ahead with that one?
So in our case, our original operation concept for the Canadarm2 Dexter was based on how the shuttle arm was operated, with astronaut driving at every step. But what we do now looks nothing like that. CSC Flight Control Room, which hosts the CSC Flight Controller, is now used a lot. The development of our ground segment is a big part of the ground. Completely controlling the robots from the ground is now most of the way we operate. So we work also with the American and the Japanese partner. We also added the capability to capture free-flying cargo vehicles. So since 2009, we have done 43 free-flyer captures. We also have unexpectedly become a key provider for robotic services to external payload. So as a result, the demand of our robotics has gone up and up. So we have started also developing autonomous control on our ISS robots. So this will become the basis for how we design and operate on our future systems.
Mr. Sakai, do you want to weigh in on this question of what you can do now that you couldn't do 10 or 15 years ago?
Yeah, we are able to proceed a variety of utilization that were not originally expected due to the great efforts of engineers and researchers on the ISS. For example, there is a research in space medicine that will be useful for future human exploration, and the private sector is actively utilizing the ISS. We are also trying commercial components in ISS. The success of Crew Dragon is also an epoch-making event. If I may appeal to you, the Japanese experimental module Kibo has both a robotic airlock and a robotic arm to conduct CubeSat deployment and material exposure experiments. They were developed by an engineer's idea after Kibo became operational. We have learned that assets having expandability fosters the utilization and future needs. I also believe that one of the achievements is that ISS international partners have been also to discuss and consider the gateway, the next human space station based on the ISS cooperative experiments of the ISS program.
Has the International Space Station changed your countries and your country's aspirations in space? This is something I would like all of you to respond to, but Mr. Krikalev, why don't we start with you? Has it changed the outlook?
In the beginning, of course, although we have experience of international cooperation on previous stages, but still was a pretty big concern how well we can work together, what is going to be the result of our work, and how we will move forward together. Now we know that this partnership is working really well, and now we are looking on the station not only as an platform for current exploration, but also as a platform for future exploration. We use space station as a test bed for new technology, for new experiments that result of this experiment we expect will be useful for future space exploration beyond low Earth orbit.
Mr. Dwin, do you want to weigh into this? Obviously, countries plural in your case. Has the ISS changed things in terms of space aspirations in Europe?
Absolutely, it has changed a lot. I'm coming from a small country myself, Belgium, but nevertheless, I was able to fly to space twice. Without an international cooperation like the International Space Station, this would, of course, not have been possible. And today, we see we are actually starting a new astronaut selection in Europe in the next months. We see that a lot of countries have the aspiration to have their citizens flying to space. And I'm sure that in the future, every European citizen can have these dreams. And this is, of course, relating directly to young people who have to invest in STEM, science, technology, engineering, and math, skills that we will need to build further our society in the future. But of course, it's not only linked to human spaceflight and to what we do on board of the International Space Station. There are so many other domains in space, navigation, Earth observation, telecommunications, where we will need a lot of people. And the fact that we can work in cooperation, that there is a visible element that people can see in the sky every night and say, my citizens, they are flying there, they are working there for the benefit of humankind, has dramatically changed the way that Europeans look to space.
Luc Dubé, how about what are your thoughts?
Yeah, so our contribution, the Canadian arm, has allowed Canada to become a world leader in space robotics. It also gave us the access to a big laboratory for science and allowed Canada to have its astronauts fly long-duration mission and international cooperation. It also helps promoting the space in Canada and was key for the development of such in the industries and the academia. So it inspires future generations in science and technology education. So it's a dream to come true for many Canadians. So we are very proud to contribute to such an important research opportunities. It is largely thanks to the ISS that the space community in Canada are now setting their sight on destinations like the Moon and Mars. So for 20 years, the ISS has been a vital test bed that enables us to prepare to explore deeper into space. So the Canadian Space Agency is very proud to play a big role in this endeavor.
Joel Montalbano, your thoughts?
You know, as you heard from Sergey and Frank and Luke, this space station has inspired a generation that is going to take us from low Earth orbit, where we are today, to return to the moon and then eventually to Mars. And we're using the experiences we have on the International Space Station. You know, going back to your last question, you talked about things have changed over the last 10 or 15 years. And when we first started this project, each of the agencies had really a lot of individual projects. And what we've learned over time is if we work together and we cooperate and we combine assets and combine resources, we can do much more with the International Space Station. And that learning that we've done in the International Space Station has spilled over outside of just human spaceflight. In the science mission directorates that we cooperate internationally across the different agencies, we've taken the lessons learned from Space Station and we've used that to cooperate in those areas as well, that they based it on what we did on the International Space Station. So to me, it's been pretty cool. It's been cool to watch, and it's been just an awesome adventure so far.
And if I could just follow up on that with you, in the current world of budgetary constraints, is this kind of international cooperation necessary in space, simply from a financial point of view?
It's mandatory in my mind. You know, we've learned a long time ago that any single agency does not have the resources to do everything they want to do. But when you combine, you put all these agencies together, we can accomplish so much more, and we have been. And the cool thing is we've demonstrated. We don't just talk about it, we do it. And that's one of the best things about the International Space Station. I'm a little biased as you know, the NASA program manager, but I can tell you the people we're talking to today, I know would sign up right behind me and agree.
Mr. Sakai, we didn't get your thoughts on that initial question of how the ISS has changed your country and its aspirations in space.
I guess the ISS program and its accomplishment has changed the LEO utilization easier than previous. It is not only allowed for some special person, but for everyone having what he wants to try something in LEO. ISS accomplishment in many different areas, for example, basic science, scientific research, practical research leading to industrialization, education of use of the next generations, international cooperation, etc. And JAXA, as the only ISS participant in Asia, provides opportunities for Asian countries to utilize the KIBO while building cooperation in the space field and promoting the significance of space experiments for each country.
Space is becoming more and more of a commercial enterprise, and I'm wondering how that's going to change the ISS and potentially your partnership with one another. Joel Montalbano, you want to handle that first?
All right. You know, so the first 10 years of Space Station were dedicated really to assembly. And then after assembly, we moved into utilization, research, technology development, where we're actually optimizing the use of the International Space Station. And then in these last, say, 5 or 6 years, we've been developing this commercial market in the U.S. and working with our partners to understand, you know, what it means to them and how we could help and how we can utilize the great space station we have. You know, in our mind, we've been able to optimize with these commercial partners the use of the International Space Station. This weekend, we had the 100th launch of the Falcon 9 rocket. And, you know, because we've helped develop that rocket, we've helped develop the Antares rocket for Northrop Grumman. And we've taken those activities as well as other activities, and we brought items to the International Space Station. We opened doors to the International Space Station for additional research and utilization, technology development on board. And now we've opened these opportunities to commercial, and it's not just NASA. Russia has done it, Canada has done it, ESA has done it, JAXA has done it. We've all, we're all starting in different places, but we're all moving and trying to optimize the use of commercialization and use this great resource that we have on board the International Space Station.
Sergei Krikalev, you want to weigh in on that commercialization question?
I can just add what Joel said, that we really started from some simple things like we were flying tourists or flight participants, as we call them, to space, and it was only one side of commercialization. But now we see much more opportunities, such as commercial experiments, and we know that some companies need some data using the space environment, and we can use it. Space station can be used to provide this data. So the variety of commercial application is much bigger than it was a while ago.
Frank DeWin, from the European perspective, any downside to the commercialization, or is this all a big plus?
Well, the main is a big plus, of course, and again, it shows very clearly the agility of the partnership, because we have done so many new things with this partnership under this agreement that was signed now probably 25 years ago, and that we have been able to adapt to the new environment and to the new world. Of course, it also puts some strains on the system, because the commercial companies, they want their data quicker, they want better access, they want easier access. So it also strains on our side the way that we operate. We need to completely, continuously rethink what we can do, how we can better now service a customer, another customer, because initially our customers were only the scientists and they were used to work with us. Now we have to get used to work with other entities that have other drivers. So it's not always easy, but it shows for the agility of the partnership that, again, not one of the agencies apart is able to do that, but through the cooperation, through exchanging experiences, how we do that, we are able to manage this great new endeavor. And at the end, of course, the aim is to build an economy in low Earth orbit. The aim is not that we as agencies, we continue to operate and to fly and to build everything in low Earth orbit, but that there is a real economy and we are just one of the users of the systems that will be there. And then we can focus, as was said already by a number of our guests, we can focus on exploration, the gateway, going to the surface of the moon and eventually to Mars. This is where we should have to shift our focus of the agencies in the next 10 to 20 years.
Could I just follow up a moment and ask you about the strains that the commercial enterprises are putting on the system? Can you be specific about what you're talking about?
Well, of course, if you have a commercial company that says, I want to do my research on board of the space station, they want to have, of course, a guarantee that they can fly. They want to have a return on investment. That's everything that is there about the commercial companies. So how do we manage this as agencies? How do we put the priorities right with our member states, especially in ESA, because they fund the national science? How do we manage all these different inputs that we are getting, these different requirements that we are getting? And this is something that we need to learn. We are not there yet. We are not fully 100% proficient yet, but I'm sure that we will get there over time.
Looking back on the challenges of designing and also building the space station, I'm wondering, Sergei Krikalev, what advice you might have for future projects that are this complex?
I think what we experienced from very beginning, that on top of regular work relationship, we start to build a personal relationship inside the program. And I think this is very important because in this way, we can trust to each other, we know each other better. And I think from my point of view, at least, it's one of the big advantages we have through this program, because now I have friends in Europe, in European Space Agency, in States, in Canada, in Japan, and with some people we work closer together in space, with some people we were working together here on the ground and mission control. But I think this is probably one of the reason why our program was successful, because we start to build trust to each other, and I think it's based on a personal relationship, and I treasure this as a part of my life experience.
And in terms of the challenges of designing and building, what did you learn? What would you do differently if you were to do it again, Mr. Krikalev?
I think we have different learning on different stages, because sometimes we try to do things standard, and it has some advantages, but also the life shows that things still different. We have one voltage on Russian segment, we have different voltage on US segment, and it has pluses and minuses. And because station is basically the lab where we can learn what is the best way to operate, having a variety of technical solutions. We will have more data, and even if we found out that one of the solutions is not as good as another, but if we wouldn't try, we wouldn't know about this. So I think having this variety is also good for the station and for the program in general.
Mr. Dubé, what are your thoughts on this, on the challenges of design and build and what might be done differently?
Yeah, I think the fact that it's so complex, there's a need probably to have continuous communication between the partners, especially during the design phases, because there will be a lot of changes that will impact each other. So we need to better define the interface and well define also the role and responsibilities of every partner. I know, like on the ISS program at the beginning during the design phase, we had a couple of changes over time, and that impacted us on our design for the Canadarm, and it cost a lot of money and also had a big impact also on the schedule. So those need to be defined clearly and also on a regular basis to make sure that at least we could react quickly on those changes. So,
Joel Montalbano, do you want to weigh in on this as well? How future projects that might be very complex might have learned from the ISS experience?
You know, my biggest advice, and I talk to our Gateway folks all the time, is you can't start soon enough talking globally. You got to get out of this idea of, you know, a single agency item. This has to be a global endeavor. It has to be a global partnership. And the sooner you can start working together, and the sooner you can start sharing, you know, desires, needs, requirements on how you want to operate, to me, you can't start early enough. It's a huge benefit of the International Space Station. You know, when we first started, you know, we were all kind of getting to know how each other operates, and you can imagine that comes with some different challenges. You know, think of a marriage. You start with a marriage. It's you're starting to learn each other. Today we operate, and again, I'm probably a little biased. I believe we operate seamlessly. You know, when we have an issue, we're ready to work together, and we can solve things so much quicker today than we did in the early days. And it's because of what we've done on, you know, with our global partnership. And so I tell the Gateway guys all the time, start early and keep pressing in that direction.
And specifically, I presume when it comes to design and build, you have to get talking to one another at the design phase early, correct? Absolutely.
Absolutely. And, you know, it's you know, this pandemic makes it hard, right, for some people, and it's harder for us, you know, no doubt. But the beauty of Space Station is because of all the different time zones, we've already been operating remotely. We got a lot of practice in the International Space Station. So while the pandemic has added different challenges, we can't see each other face to face like we need to, and like we've done in the past. We have some experience on this, and we're able to use that. So I'll tell you that while the pandemic's been hard on everybody, it could have been a lot harder if we didn't have this partnership already well established.
Somebody else want to weigh in on this question of boundaries being pushed out further and further, and how the partnership can help enable some of these very ambitious missions that are now on the drawing boards? Sergei Krikalev, you want to take a stab at that?
Joel already talked about this, that if we work together, all the time we work in some limits. We have financial limits, we have work resources limitations, and working together, we can, inside the same limits, we can move much further. Combining our efforts, we can do more things than we would be able to do if we work alone.
Mr. DeWin, I wanted to ask you this same question about pushing out boundaries and how the ISS lessons can be applied and will enable future missions.
Yeah, absolutely. I think it's mandatory that in the future, if we want to go further, that we will have to cooperate, that we will have to work together. And again, the friendship and the trust, the word trust was used a couple of times, that we have built in this partnership has allowed us, for example, to move much faster in the way that we have set up the Gateway program. But the Gateway program is, yes, it's going towards the moon, but at the end, we all want to explore together the surface of the moon. And even later on, we want to go to Mars. And this will be impossible if we don't continue to build this trust, build on the lessons that we have learned from the ISS, and yes, work together in ever more complex missions and ever more complex systems, because yes, the ISS is very complex, but imagine that one day we have to fly with 6 or 10 young people to Mars and bring them safely back. The complexity of that today, I don't think that we can even imagine. And so we will need all the forces and all the minds, bright minds in all the agencies that are there around the world.
Joel Montalbano, I'd like to come back to you. You have offered a few thoughts already on what other space agencies might learn from the ISS experience. I'm wondering if you have any additional words of wisdom that you would like to share.
Probably in addition to what I've said, is my words of wisdom to them would be just get started. Try, you don't have to go for the biggest success right off the bat. Try and fly a payload or two on the International Space Station. See how that works. Try and understand the processes. Allow us to show what we can do as a partnership. Fly a small payload, then fly a larger payload, then fly a person on board. You see some of the work with UAE, United Arab Emirates, where they flew an astronaut on board the International Space Station. So they're taking steps over time. Get in the game would be my biggest, my next set of wisdom, is just get in the game and let us play together.
Mr. Sakai, do you have any thoughts on this that you'd like to share with others?
Yeah, I'm not sure that this is the appropriate word, but ISS program allows to stay non-ISS partners or participants astronauts at the ISS. As you may know, Roscosmos has already mediated several private astronauts. The Crew 1 launched successfully on November 15th. So I guess the era of commercial human space flight will open up soon. If the country hesitates the human space flight, not learning human space environment or its difficulties, I recommend to try the onerous service of ISS utilization to demonstrate the technology for the human space environment. Through this demonstration, they can learn the philosophy of a human space flight and the detailed requirement of human safety. In the future, human space activity will expand from the LEO to the moon, but further we go, the greater the cost of transportation and communication, and the greater the technical risks. It is difficult to carry out a mission in a single country, and I believe that the most economical and efficient way to carry out a mission is for the countries to cooperate with each other in a mutually beneficial relationship. I hope a lot of countries develop their own strengths and promote international cooperations using their strengths as a contribution.
Mr. Krikalev, do you have any additional words of wisdom you'd like to share with some other space agencies around the world?
I would like to say that human space flights is very wide area, and it's not necessarily to fly personal to space to be participant of this human spaceflight exploration, because space or human spaceflight related science, it can be life science, it can be fundamental physics science. There is a big variety of activity that can be done by especially new agencies. They can do specific scientific experiment. And in many cases, it can be done on automated spacecraft, on satellites. But in many cases, it's much more efficient actually to do on human space flights. So really, space station is a very good test bed for new experiment, new tests, preparation for future flights, and being participant in this has very many different applications.
I want to thank all of you for your comments and reflections on what has been just an incredible International Space Station adventure. I now want to bring back Shelley Brunswick, who is the Chief Operating Officer of the Space Foundation, who has a special presentation for all of you.
Thank you, Jean, and thank you to all the International Space Station partners for that very inspirational conversation. You make all of us very proud because you show the world what is possible when we all work together to do bold things. And that is why I'm rejoining you in today's program, as it is my privilege to bestow a very special award to each of the ISS partners. It was our hope to present these awards in person to the 5 partner nations at our annual Space Symposium this year. But the best laid plans sometimes encounter unforeseen conditions that require us to adapt to new situations. And that is what we are doing today with this virtual ceremony. For over 2 decades, our Space Achievement Award has recognized individuals or organizations that have demonstrated space achievement, breakthrough space technology, or program or product success representing critical milestones in the evolution of space exploration and development. Its recipients are a who's who of the global space community, and today we add your nation's names to that distinguished list. In the 20 years since the hatch opened and the crew of Expedition 1 claimed it as our new home, citizens from more than a dozen countries have visited the ISS to live, work, and advance the human adventure and exploration of space. In recognition of their shared leadership, initiative, and investment, the Space Foundation presents its 2020 Space Achievement Award to the 5 space agencies that have led the ISS program since its inception. The National Aeronautics and Space Administration for the United States of America, Canadian Space Agency for Canada, European Space Agency for its 22 European members, Roscosmos for the Russian Federation, and the Japan Aerospace Exploration Agency for Japan. On behalf of Space Foundation and the team, I want to congratulate all of these organizations for setting the example of how effective teams work together to benefit all of us. Thank you all, and congratulations.
Thank you, Shelley. And we'd like to give each of the recipients an opportunity to make a few remarks. Joel Montalbano of NASA, take it away.
Well, first of all, let me show the award. It's an honor to receive this award, and a huge thank you to the Space Foundation for the award and for recognizing the international partnership. Like we've talked about today, the 20 plus years of operations on the International Space Station have taught the world how to cooperate globally. In my opinion, we've set the standard on how to do that, and to be recognized for that is just outstanding. So on behalf of NASA and our partners, and I know our partners are going to get a huge, they'll be able to talk as well. I just wanted to say a huge thank you to everyone, and I promise you we'll continue this great operations of the International Space Station for many years to come.
Thank you. And now Frank DeWin of the European Space Agency.
Yes, also on behalf of the European Space Agency, thank you very much to the Space Foundation to give us this great reward. But it's a reward especially for the people, I think. There are thousands of people working every single day seamlessly around the globe together to make sure that 6 of our citizens can fly safely in space, can operate, can do science, and can work for the benefit of humankind. So to all those 1,000 people in all our agencies, thank you very much on behalf of ESA, and thank you, of course, to the Space Foundation for giving us this great reward.
Luc Dubé of the Canadian Space Agency.
Yeah, so I would like also to thank you for that award. It's a great honor for me to receive it on behalf of the Canadian Space Agency. So I will share it with all the CSA employees who supported this program over these years, and also with the Canadian industry, particularly MDA, who also contribute to the success. So we now control the ISS robots from the ground and continue to evolve with the addition of the autonomous control. So the Canadarm2, along also with the shuttle arm, basically build the ISS. So Canada will continue to partner with the other spacefaring nation, and we will continue to evolve. So thank you.
Let me give the floor to Junichi Sakai of the Japan Aerospace Exploration Agency.
Yeah, thank you very much to Space Symposium. And it is a great honor to receive such a glorious award. And Japan joined the ISS program in the 1980s. In the beginning, Japan has less experience and achievements in human space activity than the US and Russia. And I heard that it was difficult to carry out the program. I have been working on the ISS since 1992, and I am very impressed with the 20th anniversary of human mission in the ISS and the various accomplishments it has produced. I hope that this partnership on the ISS will benefit its partners and humanity, and that it will continue to grow not only at the ISS, but also beyond the ISS. Thank you very much.
And Sergei Krikalev of Roscosmos with the Russian Federation.
And I would like to continue what Frank already said, that this award is an award for a huge number of people working in different countries, working together, and some people on very important positions. Some of them just new engineers and scientists who just recently joined the program. And I think this award belongs to all this big crowd that actually built even something before this program started, because a lot of things NASA inherited from previous program. The same with us, some engineers who developed hardware for Mir station. A lot of this technical solution was adopted for International Space Station. So I think this award belongs to all these people. And I think it's very important for new generation who is just coming to motivate them to see how it was done on previous stages, and probably several years later, new team will receive new award. So thank you all for doing all of this.
Congratulations to each of you for receiving the Space Foundation Space Achievement Award. And thank you also for participating in this conversation today. We're grateful to everybody for taking part in this, and we look forward to even more shared adventures living off of planet Earth and a future with even more bold milestones. Thanks so much.
And liftoff. Liftoff of the Proton rocket and the Zarya control module. The International Space Station is underway.
We have booster ignition and liftoff of the Space Shuttle Endeavour with the first American element of the International Space Station, uniting our efforts in space to achieve our common goals.
Roll program.
The first two pieces, the Zarya module launching from Kazakhstan and the node Unity from the United States, the first time those pieces ever touched each other was 250 miles above the Earth, traveling 17,500 miles an hour. They fit together perfectly, and the electrical signals across the interface was perfect, and yet that was the first time they had ever seen each other. we all pull together as a partnership, both the United States and Russia, but really also Japan, ESA, and Canada all pitch in and help each other through these times.
Thank you to our ground support teams.
And we really respect your professionalism.
2, 1. Ignition. We have ignition and lift.
When we're up on orbit, we were pretty relieved to have all the risk of launch behind us. But then there was kind of a very busy scramble, particularly to find the TV hookup and the TV cable so we could give you that downlink. We were really close to the wire, getting that all rigged and happy, and we almost missed it.
Go ahead. Have a good day.
We finally got access to the internet. We're really happy with it because it helps us feel like we're a little bit more in touch with the world below us.
Shall we start taking this symbol of partnership and friendship and competition into space?
People who explore, people who venture into the frontier will want to share the experience. It's an amazing experience. We have the internet and we can get the story out to more people.
So if we step away and we can look at the Earth from above, we can get a very good feel for all of the dynamic changes that are happening both in the ocean, in the atmosphere, on land, and so forth.
This is the cupola. It's one of those places you find yourself hanging out in all the time because all you want to do is look back at our planet. I play this game with myself about where we're flying over the Earth. You can sort of figure it out. You can tell different cloud types over different continents. You can tell different soil types over different continents.
Oh wow, the Baja Peninsula. My favorite things to look at. Nice. Wow. That is amazing.
I've definitely drawn encouragement from mentors, and so recognizing that we may be offering that for future space explorers was definitely a privilege and an honor. We have a gift and an opportunity to potentially inspire the future.
It's unbelievable that like something that I am doing is going to be like in space. So I'm just like, wow.
I think this has a really neat potential, you know, something that wasn't available when I was growing up, but where the students themselves can actually participate in what's going on board station.
First, we see these pure discoveries, where out of the blue you learn something nobody had a clue, and it changes the way that a discipline thinks about itself forever.
We're studying the long-duration effects of spaceflight on humans and on the life support systems that are required to support our life, working and living in space.
We're most interested in understanding the human body in zero gravity because we want to go beyond a low Earth orbit and explore.
Also, we have this applied research that leads us to real Earth benefits, where we go out, we seek information, and we bring that information back to Earth and directly start impacting people's lives.
Today, experiments have been run on boards that have touched over 103 countries around the world. So it's something that the whole world can be proud of.